All right, let's go and take a look at our polynomial. So one thing we're also going to want to work on is just using our rules of exponents. Okay. So we're going to cover like a lot of rules of exponents here and just kind of do a quick little good review for you. So the first thing, this one is going to be the power to product rule. So basically whenever you have, as long as you have terms separated by multiplication, you can go ahead and distribute that power to each and every one of those terms. So in this case, I have a 3 to the 4th power. So this basically can write it like this, 3 to the 4th power. I don't know why I wrote my x like that. Let's just go ahead and delete that. So this would be a x to the 4th. Keep on forgetting things. So that'd be an x to the 4th. Let's try this again. There we go. 3 to the 4th times x to the 4th raised to the 4th. And then this would be a y to the negative 3rd raised to the 4th. Okay, so now in this case, what we can basically do is now to simplify. So 3 to the 4th power is going to be an 81. X to the 4th raised to the 4th is going to be an x to the 16th. And then this would be a y to the negative 12th power, right? You multiply those powers. And then just remember that whenever you have a negative power, you can rewrite that as a positive power by writing it as the reciprocal. So my final answer is an 81 x to the 16th over a y to the positive 12th. Over here, I'm just basically multiplying these. So this is going to be a 81 times a 9. And 81 times 9 is, I should probably know this on top of my head or be able to do it, but I'm not really sure. So that'd be 720 times 9. So yeah, that makes sense. So therefore, the answer is 729. Now, remember when you're multiplying exponents, you multiply your numbers. And when you can multiply exponents as long as they have the same base. But remember, you're going to add the powers. So therefore, this answer is going to be a negative 10. And then 2 plus 7 is going to be a 9. Over here, remember, I can rewrite this with a positive power by rewriting it as the reciprocal. So therefore, I can say this is a 3c. Instead of dividing by a c to the negative first, I can multiply it by c to the first power. Well, this is also being raised to the first power. So my final answer here is going to be a 3c squared. Now, on a problem like this, what I always like to do is kind of clean up the negatives and the zeros and then go ahead and simplify. So remember, whenever it's a negative, I can rewrite it as its reciprocal with the positive power. And just remember, anything raised to 0 power is just going to be 1, right? And so I don't really need to write it there. Okay, so now let's go ahead and write what I have here. That's just going to be the y to the 4th. I'm going to bring down these x to the 3rd. Okay, then I'm going to have this x squared. I'm going to have this x to the 4th. But then this y to the 1st, I can bring that up. So basically, I just have two values that I can switch, and that'd be y to the 1st power. Now I can multiply them and add their powers. So this would be y to the 4th times y to the 1st, which would be a y to the 5th. And then this is going to be x cubed times x squared. Sorry, you're just adding the power. So 3 plus 2 plus 4 is going to be a x to the 9th power. All right. And then let's go over this one. Basically, now it's just going to be the quotient property. So the quotient property, remember when multiplication for the product property, you add the powers, right? So for the quotient property, basically you're just going to be subtracting the powers. So I have 2 over 4. That's just going to equal a 1/4. And then I have a x squared divided by x cubed. I'm sorry, let's subtract those. So that's going to be an x to the negative 1st power. And then 2 minus 4 is going to be a y to the negative 2nd power, right? So since these are negative, right, these are technically in the numerator, right, because I just provided that power. So to write this correctly, I need to write these in the denominator. So that'd be a 4 times x y squared. In this problem, we need to use the power to product rule first, and then let's go and simplify. So let's see. Remember the power product, you're going to multiply your powers, right? And when you have an exponent raised to a power, you multiply. So this is going to be a n cubed times p to the negative 2nd power. This is going to be a n to the negative 2nd power and a p to the negative 2nd power. Well, what do we know about the negative 2nd power? We can bring those up. And then this p to the negative 2nd power, we're going to bring down. But notice, before we have any need to do that, whenever you have an exponent raised to a power that's exactly the same in the numerator and denominator, what's going to happen? Those are just going to divide out, right? So really what I have here is an n cubed times an n squared, which is just going to equal a n to the 5th power. Over here, I'm just going to go ahead and distribute. So now here's an important thing is I have a negative b to the 5th power, right? So what's really important here is you can actually rewrite this as a negative 1 times a b to the 3rd power and c to the 4th power, okay? And that's all being raised to the 5th power. So technically what we're doing here is we're raising a negative 1 to the 5th power. So everything's still going to be negative. But if it was an even power, you just want to be aware of that, okay? All right. So now what we're going to do is, what else are we going to do? Yeah, just raise the power. So therefore this is going to be a negative Now remember, we're going to multiply these. So that's going to be to the 15th. This would be a c to the 20th power. And I think, yeah, everything's good. Over here, we're going to multiply. Now, the cool thing about this is when you're multiplying these exponents, since everything's separated by multiplication, you can actually just do the work. Like you can just write it as one like expression, right? So 12 x squared y to the 4th all over a 6 x. So you can multiply these. That'd be x to the 4th y. Okay. Now let's just go ahead and simplify this. Now, another way to do it, rather than like subtracting and getting negative exponents and dividing, what you can do is just like reduce everything how it is. Like if I have x squared over x to the 4th, like I can divide a 2 on both sides. That's going to give me a, if you divide, let me think about it another way. Yeah, if you divide out a 2, that'd be a 2 it's not really dividing out the cancel. You're basically like canceling out those terms. So the way I explained that was kind of confusing. So it'd be x to the 4th. Okay. So basically I have an x times x, right? Over an x times x times x times x, right? So those two are going to be divided out, leaving me with just an x squared in the denominator. 12 over 6, that can be divided to a 2 over 1, right? And then a y fourth over a y to the 1st power. I can divide out one y on the top and bottom. That's going to give me a 3. So I can divide out 2 of those. That's going to give me a 0, actually. So when I divide out a squared, that's going to go like that. That's going to leave me with the 2. That's going to give me a 0. Man, I'm having trouble here. That's going to be 0, and that's going to be 2. Okay, so now what I'm going to have is x to the 0, which is just 1. So that'd be y cubed, and then that's going to be all over. That reduces to a 2 over 1. And then this is going to be a x squared. So my final answer, I'll just write it a little bit better, is going to be a 2y cubed over x squared. Okay, another one over here is go ahead and again distribute. Okay, now again, that's going to be this is really important though, because what I want you to understand is like this negative here, this is a -1, right? So that's a -1 to the -3rd power times a 2 to the -3rd power times an x to the -3rd power times a y to the -3rd power. I'm sorry, I said that wrong. That's let me do this. It's so I have the 2 raised to the -3rd power. That's an x to the -3rd power, right? And that's a y cubed to the -3rd power. Okay, so -1 to the -3rd power is going to be a 1 over -1, which is still just a negative. So it doesn't matter where you put it. We can just put that in the numerator, right? But over here, this is going to be 2 to the -3rd power is going to be a 1 over 8. Here is going to be a 1 over x. And here is going to be a times a 1 over 9. So therefore, my final answer is 9 times 8 is going to be a 72. So therefore, this is going to be a -1 over a 72x. Okay, so now let's get into factoring some polynomials. And this is definitely something that you are going to want to make sure you are familiar with factoring polynomials. So whenever you have 4 terms, right? We talked about factoring quadratics. That should be like a staple of your ability, like your math up to this point. But when you have 4 terms, what we're going to want to do is look for grouping. So when you're doing grouping, the main thing you want to do here is just kind of rewrite this. Like you understand, like subtraction can be the same thing written as like an addition problem, right? Plus a negative is the same thing as subtracting, right? So if I say 5 minus 4, that's the same thing as 5 plus a -4. So what I'm going to do, just to be mathematically correct, I'm going to write this as plus a -5x. All right. Then what you're going to do is you're going to group the first 2 terms and then group the last 2 terms. All right. Then what we want to do is factor out what these have in common. So in this case, they have a 2x in common. So that's going to leave you with a x squared. So I factor out a 2. That's going to be an x squared plus 9. And then over here, I can factor out that's not an x squared. That's just an x. Going crazy. Okay, so then over here, I can factor out a -5, and that's going to leave me with an x plus 9. So when factoring by grouping, these 2 terms have to exactly be the same. Because otherwise, then you cannot factor it by grouping. Or it might not be factorable. So since these are both the same, and both these expressions, do you see how I have an expression here, and then I have an expression here? They're separated by subtraction, so they're different expressions. But they both share an x plus 9. So what that means is I can factor out an x plus 9. And what's going to be left over? What's going to be left over is a 2x minus 5. And that is going to be your factored form. So let's go ahead and do that again. So in this case, I have x cubed plus 5x squared. And I'll just say, put a little plus there, minus the 9x minus 45. So again, group those. All right, what do these have in common? They both have an x. So that's going to be a x plus 5. I'm sorry, yeah, x plus 5. And then over here, I can factor out a 9, and that's going to leave with an x plus 5. Okay, again, they share the same thing. So you factor out the x plus 5, and that's going to leave you with a x minus a 9. Now here we have a trinomial, right? So again, you always want to be able to see what can you factor out. Well, how do you factor out something raised to the third power as it is a trinomial? Well, again, you can factor out this x, and also I can factor out a 3. I can't factor out a 9 because 9 doesn't even divide into 12. It doesn't go into 45, but it doesn't go in there. So I can factor out a 3. So by factoring out a 3x, I'm now going to be left with a 3x squared plus a 4x, and then let's see, that's going to be a minus a 15. Cool. All right, now we want to see, is this factorable, right? Now we want to go back to what we learned in factoring quadratics. So I want to say, all right, I can break this up into a product of two binomials. I need two numbers that are going to multiply to give me 15. So we have some options here. I don't want to use 15. I'm probably going to use 5 and 3. And am I going to get a difference of 4? Well, if I did 3 times 3, that's 9. And then with 5, that would give me a difference of 4, right? So I want this to be a positive, and then this would be minus 5. So 3x times 3x is 9x. That works. That's 4x. So that's positive 4x. Perfect. And that gives me negative 15. Cool. And that'd be multiplied by 3x. And that's going to be my simplified answer. All right. Now we need to get into long division. So if you recall or remember, we got to remember how to do division with polynomials. Okay. So when we're doing division with polynomials, the main thing we're going to want to do is set up the long division algorithm. So in this case, I'm going to divide here. So what I'll do is I'll take a c squared plus a 3c minus 2. And then I'll have a c squared minus 3c squared plus a 18c minus 16. Okay, so for long division, we're going to take the first term, divide it into the first term of our divisor. Here, c squared goes into c squared. How many times? That's just going to be a 1 time. So then 1 times c squared, and then 1 times 3c. So that's going to be a positive 3c. And then a 1 times negative 2, and I'll write that over here. I don't have anything here, so I can just write a 0c squared if I need to. Now what I'm going to do is go ahead and subtract my 2 rows. So c squared minus c squared is just going to be 0c squared, which is 0. Negative 3c minus a 0. So basically, you can just bring this down. So that's going to be a negative 3c squared. That just goes in there. Oh, that was c cubed. No, I was wondering, like, why did that not make sense? This is all wrong. Let's go ahead and redo that. It's like not 1. That doesn't make sense. That's c cubed. C squared goes into c cubed a c number of times. So therefore, this gives me c cubed. C times a 3c is going to be a positive 3c squared. And c times negative 2 is going to be a negative 2c. Okay, now let's bring this down. Since there's nothing with the 16, I can just put a 0 here as a place value. Okay, so now let's go ahead and subtract our rows. So c cubed minus c cubed is just going to be 0. Negative 3c squared minus a 3c squared, right, is going to be a negative 6c squared. 18c minus a negative 2c is going to be a, let's see, that's going to be positive 20c. And negative 16 minus 0, it's just going to be negative 16. Okay, so now let's just do it all over again. How many times does c squared go into a negative 6c squared? Well, that's just going to be a negative 6 times. Negative 6 times c squared is going to be a negative 6c squared. Negative 6 times 3 is going to be a negative 18c, and negative 6 times 2 is going to be a positive 12. Okay, and again, we're just going to subtract our rows here. That goes to 0. That goes to a 38c, and this is negative 16 minus 12 is going to be a negative 18. Okay, so that is going to be what we call, this answer right here is going to be what we call our remainder. So here's our quotient, so we can write it as a final answer of c minus 6 plus a 38c minus 18 all over your divisor, which is a c squared plus a 3c minus a 2. Okay, so that's the long division algorithm. You're gonna need to know the long division algorithm, but you're also gonna want to make sure you remember synthetic division. And for synthetic division, basically all we simply need to do is just set our divisor, right, equals 0. So then x equals a negative 2. So now what we're simply going to do is take the coefficients. So we're going to take the coefficients of our dividend here. And notice how I don't have a cubed, right? So when I don't have a cubed, what I'm simply going to do is use 0 as a place value. So I have a 1, 0, or a placeholder, negative 2, negative 1, and 2. All right, so now let's just follow the synthetic division algorithm. So I bring down the 1, and then you multiply on the diagonal, add on the vertical. So 1 times negative 2 is a negative 2. 0 plus negative 2 is going to be a negative 2. Negative 2 times negative 2 is going to be a 4. Negative 2 plus 4 is going to be a positive 2. 2 times negative 2 is a negative 4. Negative 1 plus negative 4 is going to be a negative 5. Negative 5 times negative 2 is going to be a positive 10. 2 plus 10 is going to be a 12. So now this answer looks a little bit different than that answer, right? So what we need to understand is, how do we write this out? Well, that's your remainder. That's your constant. That is your coefficient of your linear term. This is going to be the coefficient of your quadratic term. And here's the coefficient of your cubic term. All right. So I can write my answer now as a x cubed minus a 2x squared plus a 2x minus 5. And remember, we have a remainder, right? So it's going to be plus a 12 all over my divisor, which is an x plus 2. All right, so let's go and do the exact same thing again here and just go ahead and set all these up. So again, I can set my divisor equal to 0. Hopefully recognize that's just going to be a 1, right? And then let's go and take these values here. Let's go and move this over though just a little bit. Okay, so what I'll have here is a negative 2. I have an x and a negative 6. That's good. So I'll do an 8 and a negative 6. Okay, bring down the negative 2. Negative 2 goes times 1 is going to be a negative 2. 8 plus negative 2 is going to be a positive 6. 6 times 1 is going to be 6. So therefore that's 0. So therefore that's my remainder, my constant, and my linear term. Therefore my answer in this case is a negative 2x plus 6. Okay. And basically what that means again is x minus 1 times negative 2x plus 6 is going to equal that, right? So that's that understanding of that. All right, let's just go through a couple more examples of the expanding our binomials or expanding polynomials. And because that's going to be something really helpful for you to make sure that you can do rather effectively. So the main thing I want you to really understand here is, just apply distributive property. So, you go like this, right? Multiply the x times everything, and then you're going to multiply the negative 3 times everything. All right, and you can do this using the vertical or the horizontal method, whatever kind of works for you. I usually like to just do the horizontal method, meaning just going to write out all the products and then find my like terms that I can combine. So x times x squared is a x cubed. X times 2x is going to be a 2x squared. X times negative 3 is going to be a negative 3x. This would give me a negative 3 times x squared is a negative 3x squared. Negative 3 times 2x is going to be a negative, I'm sorry, that's a negative, so I said it, but I didn't write it. Negative 3, that's going to be a negative 6x, and negative 3 times negative 3 is going to be a positive 9. All right, so that's everything. Now let's just figure out what like terms can I combine. Well, I can combine my x squareds, and I can combine my x's. So therefore, I get a final answer here of a x cubed. That's going to be an x cubed, an x cubed, and then 2x minus 3x. That's going to be a negative x squared. This is going to be a minus a 9x and then plus a 9. Okay, so yep, looks good. All right, now in this case, there's a couple different things I want to do. Please, whatever you do, do not do this. X cubed plus 4 cubed. That happens all the time, happens every year. Don't do that. Remember, x plus 4 cubed is a x plus 4 times an x plus 4 times an x plus 4. Okay, so the way I like to do this is, for the first one, I think you can probably do distributive property or FOIL rather easily, hopefully. And I can go and expand this. So x times x is x squared. 4 times x is 4x. 4 times x is 4x. 4x plus 4x is going to be an 8x. And 4 times 4 is going to be a positive 16. Okay, and then x plus 4. Now, you can do the rest of the problem like this, but if you kind of notice there's a lot of things kind of going on, I think sometimes it can be easy to make a mistake. So another technique you can use is use what we call the box method. And the way the box method works is you basically take one product and put it along a box. And then you take the other product or the other term in your product and you write it along the other side of the box. So this is an x plus 4. There's 2 terms, so I'm going to write 2 rows. Now this is going to be an x squared plus an 8x plus a 16, which has 3 terms. So I'm going to do 3 columns. Now, all you're going to do is basically find the area of each of these boxes. So you're just basically going to multiply length times width. So x times x squared is an x cubed. X times 8x is an 8x squared. X times 16 is going to be a 16x. X squared times 4 is a 4x squared. 4 times 8x is going to be a 32x. And 4 times 16 is going to be a 4, 16, 32. That's going to be a 64. So the thing I like about the box method is it just kind of groups things. So you can see as long as everything's on a descending order, everything is kind of grouped on the diagonal. So therefore now I can write my final answer here as an x cubed. 4 plus 8 is going to be a plus a 12x squared. 32 and 16 is going to be a 48. And then plus 64. And voila, we're all done.